So I was playing around with how to arrange everything. Um, yeah, so I guess everyone is really thinking about um, the fate of this new virus, SARS-CoV-2. And in particular, we know that um, obviously respiratory infections is the main way that you can get infected with COVID-19. And there's been some research on viruses in water and wastewater. And I thought that what I do is just summarize the literature and talk about what we know so far and what we don't know in water and wastewater. So, okay. Okay, so I'm sure you're here because you have some questions. So, for example, for the general public, maybe there is a concern that there may be a risk of getting COVID-19 from drinking water or maybe from wastewater or sewage. Are there other transmission pathways than the ones that we know about, including obviously the respiratory pathway? Maybe there are water professionals in this group, and one question is, what's the risk of getting COVID-19 from working at a water or wastewater facility? And also, how can we best protect the public? Or maybe you're coming from an LGU, and the question is, what can we do to protect the public? So these are maybe some questions that we'll try to answer today. So as you all know, this is the main transmission pathway for SARS-CoV-2. Essentially, we talk about coughing or sneezing, releasing droplets that contain the SARS-CoV-2 virus in the air. And essentially, these droplets then make their way into the nose, the mouth, and then possibly into the lungs of another uninfected individual. You've heard about these droplets maybe falling on surfaces and objects that somebody else who's not infected can then touch, and then basically that can go inside and into their nose and mouth. But are there other pathways? So, for example, see if this is working. Okay, wait a minute. Is the virus being shed by actively infected individuals in feces? And are there discharges to water that we should worry about? And if there are, what's the extent and what's the risk of getting these discharges to water going into this respiratory pathway? Or maybe there is a fecal oral pathway. So I'd like to start by actually first talking about water and wastewater in a city or town, and I'm going to call it, one water. And essentially, this is a way of thinking about a whole city and how the water is going around in a city. So, for example, you might have a river, a source of water, or a lake or a reservoir, and the city takes in water to a water treatment plant, and that's treated in that water treatment plant. And then after it's used, that city is going to discharge it into a sewer line. So we go on this side. Now this wastewater goes into a wastewater treatment plant, and that wastewater treatment plant treats that water before discharging that into a receiving body of water. I took this picture from this website because it actually shows some interesting lines also. So the traditional pathway is you get fresh water, you treat it, you go to the city, and then the city discharges that dirty water, that wastewater, and that's treated before it's put back into a receiving body of water. But actually, this is showing all these other purple lines that are reuse or water recycle options, including, for example, that same wastewater being the source of drinking water for another city downstream. And this particular drawing is a little bit weird because this, this is showing basically two cities, right? But this is happening all the time. Somebody's wastewater also becomes somebody else's drinking water. An example is where I live right now. where the towns, the cities of Durham, um, the South treatment plant discharges into this lake, and that lake actually is the drinking water source for another town, Apex and Cary, here in North Carolina. So that's basically how water goes around. But what you can think about is, if SARS-CoV-2 is in all these waters, what are the possibilities that we might be exposed to these waters? Okay. So I wanted to put this in the context of Metro Manila, and this is showing the drinking water supplies in Metro Manila. And as you know, if you are in Metro Manila, oops, I hope you can still see that, okay? That there are two zones. The east zone is where Manila Water Company Incorporated operates, and then the west zone is operated by NILAD. And I know some of you know this, but just to review, the water for all of Metro Manila comes basically from these reservoirs upstream. The Angat, for example, some of that is being used for irrigation. And then you have the Ipo Dam, and then essentially that is eventually piped through aqueducts into La Mesa Reservoir. A portion of it goes to this La Mesa treatment plant, and that's operated by Maynilad, and that water then is treated, and then that goes to the west zone. La Mesa Reservoir is the source of water for the Balara treatment plant, and that basically is operated by Manila Water, and that's the water that goes to the east zone. So that's the drinking water side for Metro Manila. I just wanted to put that in context. So now let's talk about what happens. So what's the likelihood of SARS-CoV-2 surviving water treatment processes? And this is a cartoon, if you will, of a simplified water treatment process. And pretty much most water treatment processes in major cities have this, including Metro Manila. So you have all of these physical processes from the intake, you add chemicals, you flocculate or take out the solids. The most important thing is actually this part here, this filtration process here. And then this disinfection process. Here in this cartoon, it's showing up as chlorination, but this can also be UV disinfection, ultraviolet disinfection. And that's important because these typical water treatment processes have been found to be very, very effective in controlling and inactivating enveloped viruses like SARS-CoV-2. So SARS-CoV-2 is actually really easy to disinfect. It's in fact easier to disinfect than all of these other things. So this is a hierarchy of resistance that the Centers for Disease Control in the US, this is their figure. And so the most resistant is actually at the very top, and the least resistant or the most susceptible are at the bottom. So you have prions, you have bacterial spores, you have protozoans like Cryptosporidium, and then you have these non-lipid viruses like the poliovirus or the Coxsackie virus, fungi, the typical bacteria that you are thinking of as pathogens maybe in drinking water. And down below are these lipid or enveloped viruses, including SARS-CoV-2. So in fact, SARS-CoV-2 can be easily disinfected. And so the typical treatment processes in drinking water would take care of SARS-CoV-2. So the risk to water supplies is quite low. So the WHO basically has come up with very clear direction. And we know this because we know the disinfection data for related coronaviruses. So for example, the classical SARS, the SARS coronavirus, we know a lot about it. These are again enveloped viruses. And what that means is that they have, as you may know, are covered by a lipid layer. And this lipid layer is very easy to destroy with surfactants, for example. And that's why hand washing is very, very important. And that's why that's the main guidance for the public is to wash your hands very well. So we know that SARS-CoV-2 is more sensitive than non-enveloped viruses to chlorine and UV. And so WHO recommends a free chlorine of greater than 0.5 milligrams per liter for 30 minutes at a pH that's lower than 8. And chlorine, for example, is more effective at a lower pH. The WHO also recommends having a free chlorine residual. What this means is coming from the from the drinking water treatment plant, from the drinking water treatment plant, you want a free chlorine residual so that as it goes through the pipes, there's still some chlorine in the pipes after it leaves the plant. And UV, in particular UVC, so this is in the 254 nanometers wavelength, is very, very effective. In addition, disinfection of SARS-CoV-2 can be achieved with all of these chemicals: quaternary ammonium compounds, chlorine dioxide, peracetic acid, peroxyacetic acids. And so in fact, the guidance of wiping surfaces, cleaning with some low concentration of bleach, these are very, very effective. Obviously, if you don't have that, even boiling is effective. And those of you who buy bottled water, I know in Metro Manila, a lot of households buy these big bottles of water, and maybe even outside Metro Manila. What I can tell you is that the water coming from the drinking water treatment plant is very clean, right? If you do have aging pipe systems, then maybe there is some issue with the water quality as it travels from the drinking water treatment plant to your house. But bottled water is safe. It's treated with reverse osmosis or ultra nanofiltration. And so we know there's very low risk basically in our drinking water. So if you drink treated water, you should not be afraid that there's any SARS-CoV-2 in that water. Now let's talk about sewage. And again, I want to put this in the context of Metro Manila. And again, we talk about the two concessionaires, Manila and Manila Water. And the main issue here is that essentially you have very, very low sewer coverage in Metro Manila and the rest of the country. That is true too. What does that mean? So typically in a sewer area, you basically have your wastewater going into sewer lines, and these sewer lines connect to bigger sewer lines, and they get to the wastewater treatment plant, like the one here on the right. This is actually a picture of the Marikina wastewater treatment plant. And, it's the largest wastewater treatment plant in the country. It's about 100 MLD, million liters per day, and can serve about 500,000 people. But even so, I'm not quite sure. This is an old statistic. This is the idea is that from 2012 to 2016, Manila and Manila Water are going to add all these new sewage treatment plants to increase the capacity. But even with these increases in capacity, the current estimate is that Metro Manila is only 15% sewered, and the rest is basically what most likely, if I'm going to guess, if you live in Metro Manila or even outside Metro Manila, I'm going to guess that you use a septic tank. So what's a septic tank? A septic tank, so before we go there, actually, what's the likelihood of SARS-CoV-2 surviving wastewater treatment? Again, in wastewater treatment, wait, I want to make sure. Sorry about that. Okay, I hope I'm still sharing. Okay, in wastewater treatment, again, you have all these processes. The most important processes, you're trying to remove organic carbon and the oxygen demand from the water. But the most important processes are this system here, a biological process, clarification. But for SARS-CoV-2 in our discussion, we know that disinfection, which is this last step right here, is going to kill SARS-CoV-2. So again, in a properly functioning wastewater treatment plant, even if you had SARS-CoV-2 coming into the wastewater, if that was well disinfected by, again, UV or chlorine And these are the two options that you have, and they're very, very effective. And so there's really a limited chance that this is going to survive. The virus. Turn to the fact that most of us in the Philippines uh, is not sewered. It's 15% sewered is actually the highest, right, in Metro Manila. Once you go out nationwide, it may be closer to 93% is not sewered. So we use septic tanks. So a septic tank is a tank that's usually on your lot, and sometimes when there's no space, it's underneath your house somewhere, right? It's basically, it's in under the floor, and you have your wastewater come in, and then you do have a physical settling process. You might have sludge underneath. You might form a scum layer. Maybe the fats, oil, and grease might fall to the top. And then the water is actually going to go in and then flow out. So there is some treatment happening in the septic tank. There is anaerobic digestion, anaerobic treatment happening here. And you have bacteria and other microorganisms that convert your wastewater. But for the most part, it goes out into the liquid. Now, in a proper septic tank, you actually have a leach field, which I don't have a drawing for here, but it's a piece of land where it goes about 6 inches below the surface of the soil, and you spray, not spray, but you spread the water, and then your waste is treated by soil microorganisms. But in Metro Manila and most of the Philippines, that doesn't happen. We don't have space, and so we don't have leach fields in our backyards. What happens really is that all of these join the stormwater line. So they join the stormwater line, and here I'm not exactly showing that because these are sewer lines. And when you have stormwater in Bornal, right, in the Philippines, stormwater as well as septage or septic tank effluent joining together, that's called a combined sewer system. But we really don't have a combined sewer system. What we have is essentially all the septic tank effluent going into these pipes, and eventually these pipes end up into the river. So we're talking eventually into the estero, like a canal, or eventually into the major river systems, the Pasig River system, the Marikina River, and so on, which obviously then flows into the bays. Now, I know that Manila Water, for example, has this concept, and I think they've done this, of really intercepting some of that stormwater and using that system to try to divert some water into a proper wastewater treatment plant. But like I said, we have limited capacity, and most of the wastewater actually ends up in the river. So why am I talking about this? Because now the question is, what happens to SARS-CoV-2? This is another slide that just talks about what I just discussed. Essentially, if you have you might have direct discharge of raw sewage if you don't have a septic tank. And so that just goes into the street drains, and this shows it going to the river. You might have a septic tank. That septic tank usually is open underneath, and it might seep to the groundwater. And again, some of that, the gray water, which is the water that's from your sinks, your showers, wash water, not the toilets, might go straight to the street to the street drains. If you do have a septic tank, this is the situation I described earlier. The overflow goes to the street drains. So you can imagine, and this is the reason why we have really polluted water in our rivers. And I know that there's been a lot of river cleanups happening, but until we have proper wastewater treatment, it's going to be a tough battle. Okay, so the reason this is important is because now we ask, does SARS-CoV-2 survive in sewer lines from the house to the treatment plant, in combined sewer lines, and in natural waters like rivers? So let's look at the evidence as we try to answer this. Okay, first of all, let's talk about when we say survive, what that means. What does it mean that you detect SARS-CoV-2 in an environmental sample. Most of the detection is using nucleic acid amplification and detection. So you might have heard about this. This is the same technology that we need to use also for human diagnostics. So essentially, we use reverse transcription polymerase chain reaction. And what we're trying to do is we're trying to convert the RNA um, into DNA with the reverse transcription, and then we use PCR to amplify and then detect that DNA. So this detects the nucleic acid inside the virus, and that's depicted here. You can see the drawing here. Uh, and it does not mean that if it detects the nucleic acid that you actually have infectious virus. Maybe infectious virus is present, but that's not positive proof. So you're detecting, if you will, the signature, right? The RNA that was present that's unique to the SARS-CoV-2. So the fact that you detect RNA doesn't mean that the virus is infectious. It may not even be structurally intact. In other words, you might have bits of virus RNA that are still present in the sample. So that's the typical way that we detect SARS-CoV-2. Now, how do you detect infectious virus? Well, you actually do this by culturing or growing. And so you actually put them in media, and in this case, you can actually grow them in host cells and count the number of plaques or that form, and call as the plaque forming units or PFUs. And then we can also quantify things like the median tissue culture infectious dose. In other words, what's the concentration at which half of the cells um, are infected after being exposed to the sample. So that's a measure basically of how much was there, right? And this is probably the gold standard in terms of making sure that what you're counting is infectious virus. So I present this because actually most of the data, there are some that talk about culturing and infectious virus numbers. But most of the data we have are using molecular methods like RT-PCR. So understanding all those caveats is important. Okay, so the first question is SARS-CoV-2 in feces? I think that's a question that we have to ask. And the answer is, and these are all studies that have been going on just in the last month, 2 months. Obviously, this started in December in China, and then in January, February, and March, and even today, people are really trying to do research very quickly. So the very first evidence came out in around February. And again, these are RT-PCR results. So this is 16 patients. This is from China. What I wanted to show you was to take a look at these numbers. These numbers are called CT values, or threshold numbers, for the number of cycles in PCR where you start seeing the DNA from the RNA being amplified. So the lower this number, the higher the concentration of original nucleic acid that was there, okay? But a number lower than 40 is usually a positive signal. That's kind of like the cutoff that most people use. So this first column is when it says OS, that's an oral swab, okay? And this second column is an anal swab. So these are patients that were admitted, and you can see that in some instances, the virus is present, and this is SARS-CoV-2 again, in oral swabs, and sometimes not in anal swabs, but sometimes you see them in anal swabs, but not in oral swabs. In other words, even though you can see them in the fecal material, you're not seeing them in the nasopharyngeal or the swabs that are taken from the throat, so deep within the throat. So what we can say is that we can detect SARS-CoV-2, and at that time we were still calling it 2019 nCoV, in anal swabs from patients, and this is in Wuhan. And again, like I said, you can detect the virus in anal swabs even if they're not detected in oral swabs. And this is probably the first report of possible fecal oral transmission pathway. There were other studies also from China saying that maybe some fraction of the patients actually also, in addition to having SARS-CoV-2, COVID-19, they are also experiencing diarrhea as one of the symptoms. Uh, in different clinical specimens, this is another study also from China, you can see the positive test results from the different samples. This is sputum, nasal swabs, pharyngeal swabs, and then feces. The important thing here is that out of all of these numbers of patients, out of 153 patients or fecal samples, 44 were positive, about 29%. And you can see that they really detect it. It's also found in blood, just 1%, but has not been found in urine. This particular study is also interesting because, again, I told you that PCR, RT-PCR is looking at the nucleic acid. We're not sure if that's infectious virus. But this particular paper essentially reported that they observed live virus using electron microscopy. And that was obviously a big thing. I'm not quite sure how you can do that. Again, the gold standard is actually culturing using, if you can culture back the viruses. But this was, big news because that meant that it's not just the nucleic acid, but possibly the live virus was observed. Here's another study, again from China. These are now children, and I put this up because these are basically different children who had rectal swabs as well as nasopharyngeal or oral swabs. And you can see just from the graphs, right, looking at the average, which is the red here. And again, the CT value is here. So anything above 40 would be positive. And you can see that there's higher numbers of virus in rectal swabs compared to the oral swabs. And sometimes there's none detect in the oral swabs, but you still have high levels of viruses. In addition, these were children who were generally asymptomatic or had less severe symptoms. And combined with having negative oral swabs, if they're asymptomatic and they don't have any, if the oral swabs are negative, then typically you wouldn't consider them as having COVID-19. But then in the fecal material, you're seeing COVID-19. So in fact, they are shedding virus even though they're asymptomatic and it's not showing up in oral swabs. Here's another paper. It's just looking at one child in the stool specimen in one child. And what I want you to look at is basically, these bars are the asymptomatic periods. So green is is the exposure time. This is the asymptomatic period, the blue. But then if you start looking at the stool samples here, it starts showing up in the asymptomatic period, the positive signs here. So you get stool samples showing up even though you don't see any in the sputum, and you never see it in the urine. Okay, so essentially, even though presumably the patient was asymptomatic, the patient was still shedding virus in the fecal material, but you don't see it in the other, nasopharyngeal swabs or the sputum. So the same kind of thing. Now, this is an interesting study. This one is quite interesting. And the reason is that, one, it's a higher number of patients that they followed. The red are basically, the red bars here are the days where the patient had positive oral swabs. And the yellow is when the patient had positive fecal samples. So you can see in general the pattern where you might see the viral RNA first in the oral samples, and then some days later, you see the fecal samples. But what's interesting is some of these patients have tested negative and they're still shedding the virus. And in fact, for a long period of time afterwards. Okay. So that was interesting because that told you that, again, just like I was telling you in the other studies too, there were some evidence that even though a patient might test negative with the nasopharyngeal samples or the oral samples, it's still possible that they're shedding a COVID-19 virus. Okay. Finally, we talk about another study where, again, this is comparing sputum samples with stool samples and the days after the symptoms. This is interesting because this particular study, they tried to isolate from the stool and they found no isolates from stool samples. Now, there's this one paper, which actually I haven't been able to read because I can't find it anywhere. It's from this bulletin, China CDC Weekly. And this is the only study to date to report that they were able to isolate live virus from stool samples. And I think the problem here is that it's not available, like I said. And then the second problem is that this is the only study to report isolation from stool to date, and this needs to be replicated. I think there are some researchers from Nebraska. They're doing a lot of sampling. They were among the first to report COVID-19 in environmental samples in hospital settings. And they've been trying to isolate, but they still have not isolated live virus. So that's still an open question. Okay, so let's summarize shedding. The first and most important thing is that even though we find fecal samples to have the virus and that COVID-19 patients shed the virus, fecal oral transmission is still considered unlikely, and there's no evidence to date. About 27 to 89% of patients have persistent shedding in stool. And when we say persistent, that means even days after the oral samples are negative. As far as we know, the densities in the fecal samples are about 0.8 to 7.5 log gene copies per gram. So 10 to the 7.5. Again, live virus was observed in one study, and then isolation was in one study. And again, this needs to be replicated. Can we get infected virus in feces? There's not a lot of evidence out there. So we still need to do some research on this. Now, does SARS-CoV-2 survive in sewage is the next question. Okay. So we don't have a lot of data in terms of actual survival in sewage. Not a lot. In fact, I haven't found a study that actually used the live virus or the culturing. Obviously, a lot of these are based on viral RNA detection using RT-PCR or using surrogates. So here's an example of using surrogates, and these are also other coronaviruses. This is a transmissible gastroenterovirus, so that's TGEV, and then there's a mouse hepatitis virus. And so with these surrogates, we're saying maybe the SARS-CoV-2 acts the same as these coronaviruses. So what are we seeing here? We're seeing in sewage, essentially a die-off right here for these viruses, and a 6 log inactivation after about 21 days or so. So we might say, okay, after 20 days, they're gone. But at warmer temperatures. At colder temperatures, they seem to survive much better. Here's another study, again with surrogates. And the surrogates here are feces and again, that mouse hepatitis virus, MHV. MS2 is another surrogate, but it's not an enveloped virus. So, people again choose different surrogate viruses depending on what they're trying to show. Again, you can see this is in wastewater and then in pasteurized wastewater, and pretty much the die-off, are in the order of hours. So if you look at the MHV and the Phe6 here, in the order of hours, you get 2-log removal, so 99% removal. This other graph is showing the adsorption to surfaces or to solids. So in wastewater, you have water and then you have solids. And what this is showing is that you get, about 26% adsorption of this surrogate coronavirus onto solids. And that's important because now, if we're looking for that in wastewater, are we looking for it in the water or the liquid, or are we looking for it in the solids? Will it survive in natural water? So this is another couple of studies, or same study, with just reagent water and then lake water. And again, you see in the order of days. This is a 4-log removal after about 30 days or so. So typically we say they're going to survive in the order of days, maybe a few days, 2 to 7 days, especially if it's colder. Okay. So there's a possibility. And again, some of those studies are not RNA. Those studies are actually, infectious viruses. Okay, the first report of SARS-CoV-2 detected in sewage, you may have heard of this, was actually in the Netherlands. Just came out, the preprint came out in late February. They reported this. So these are the wastewater treatment plants. They were looking at the influent of the wastewater treatment plant. And so the dates, so this is Europe. So the way they look at the dates, this is not July 2, 2020. This is February 7. And this is March 5, March 16. So as you go from left to right, you're moving forward in time. So this is February, early February. And these are the primers that they used. So this is the targeting, the N proteins in SARS-CoV-2. So N1, N2, and N3. And then another primer set. And so, it was negative here in early February, but then in March, first week of March, basically they were seeing positive for this one primer and the others are still negative. And then later on, 2 weeks later, they were seeing more positive. So this became quite a big thing because they detected in the wastewater SARS-CoV-2 RNA even before they had cases of COVID-19. So there were still 0 patients, and about, in some instances, in some of these places, there were still no patients, but they were detecting it. And so the question was, is it possible to use wastewater sampling as a way of detecting, the RNA to basically augment or help out in addition to human diagnostic testing. So if you think about it, wastewater is essentially wastewater is basically a pooled sample, okay? And this pooled sample is sampling a whole community, a lot of people in one shot. So that's the question, is that a possibility? Okay, the second report, so there were only 2 reports to date. There's a lot of people now working on this, including our group. But the second report was in Massachusetts, and this is the from the BioBot group. And these are the numbers that they had. And this is again 2 plants, the S and the N plant, the south and the north plants. And this is March 18, March 22, and so on. And you can see these are the numbers. Let's see, the units are copies, right? Sorry, I can't see the units now from where I am, but copies per gene copies per mil. So you can see that it actually is starting to increase. And what they were saying was that when they do some back of the envelope calculations, they estimate that about 5% of the population were infected based on the fecal analysis compared to the actual incidence at that time, which was about 0.03%. So they were saying that there's a lot more people infected than we know because the human testing is behind. So is there a way to actually use sampling um, of the wastewater as a pooled sample and a more accurate way of determining the number of infected people? So this has now become something that is becoming quite popular. It's called wastewater-based epidemiology. And the idea is that if you have pathogens or pharmaceuticals even, and a lot of people have used this now for pharmaceuticals, we can detect basically the level of, you know, different kinds of drugs in a community by sampling the wastewater. We can measure things like caffeine. We can measure, other things. But there's only been a few cases of using this for pathogens, and only one paper before this whole thing as a way of sampling a community for viruses. So the idea is that the population contributes to a pooled sample. You're talking about thousands, hundreds of thousands of people contributing to the same wastewater. Can we sample that and tell us something, which will tell us something about what's going on in the community? And if we can sort of use that to in models and calculate the actual load in a population, can we then help out in terms of just human diagnostic testing? Can we add that to all this other data that we are getting, and can it help public health officials? So that's a question, and not just infectious diseases, but also resistance, antibiotic resistance, and so on. To summarize, uh, detecting SARS-CoV-2 in feces show, again, no evidence for fecal oral transmission to date, but is it possible to use fecal sampling to detect the status of patients in addition to the usual nasopharyngeal sampling? And this whole concept of wastewater-based epidemiology. Okay, so most pathogens that are waterborne, we think about transmission pathways in terms of ingestion of pathogens, or maybe even exposure, skin exposure and so on. So this is the classic 5F diagram that, epidemiologists, public health people, this was quite popular. It started in the 1950s, actually. 5F because you're talking about fluids, fields, floors, flies, fingers, and foods. And the different barriers, having a toilet, having safe water, and having hygiene, so washing and having soap and clean water for washing. Now, this doesn't really apply to SARS-CoV-2 unless there is a likely respiratory pathway. In other words, is there a way that the virus can end up in aerosols? Is there a way that these fluids, and obviously we talk about fluids, big droplets hitting you in the nose, somebody sneezing or coughing, or splashing, obviously that's a pathway, right? But it still has to be somehow connected to a respiratory pathway. And then I just wanted to add this new 4F diagram from WHO, which talks about more of a risk-based approach, looking at the different hazards. But we can also think about this as, for SARS-CoV-2, is there a hazard associated with toilets? Are there risks associated to exposure to sewage? Are there other vectors and other pathways that basically lead to exposure and lead to COVID-19? So I just wanted to point this out because the 5F diagram is being replaced now with this new F diagram. Okay, so one pathway is through aerosols. In other words, it's in the water. Can it create these bioaerosols that contain SARS-CoV-2? For example, flushing your toilet. This might be a question, right? If you flush your toilet, And does it release aerosols? Do these aerosols contain SARS-CoV-2? Will these aerosols hang around in the air? What about sewage lines? Do they create aerosols as they're flowing, or as they're, one line meets another? And this is probably more concerning wastewater treatment plant workers. Even in the wastewater treatment plants, for example, in activated sludge, you're aerating the basin. And so are you creating aerosols that can then go into the respiratory pathway? Uh, so the first thing that aerosol experts will tell you, and I'm not an aerosol expert, so these are slides that are borrowed from Lindsay Marr from Virginia Tech and other experts, is that aerosolization and size are, size is the big issue, right? Obviously, there's density and so on. But if you think about SARS-CoV-2, it's 0.12 micrometers. The flu virus is about the same size. And there are some other viruses that are even smaller. Okay, and human hair is about 50 to 70 microns. Fine beach sand is 90 microns. And some of these particles, in the air that cause problems with people, respiratory diseases. These small particles, PM2.5, they're less than 2.5 microns. PM10 is less than 10 microns. So this is a very small virus, okay? But the thing is, it does not exist, naked. It's not naked when it's airborne. It actually is in a respiratory fluid. And again, imagine the sneezing, the coughing, the spraying. The idea is that that virus is in this fluid, and that basically makes it a lot bigger, right? And obviously, size determines how long it stays up in the air and how far does it go down, where does it deposit in the respiratory system. This is important because the smaller the particle, the more it will hang in the air. As opposed to just deposition, it just basically lands on surfaces and then it's gone unless it's resuspended, okay? So these are the questions. So we know that these are the modes of transmission, right? Maybe direct contact, and the reason for that is, you touch your face so many times, right? Basically a lot. I forget now the numbers, 15 to 24 times an hour or something like that. But you touch your face, and obviously, you touch your mouth, your eyes. There's maybe indirect contact, large droplets, and then aerosols is the big issue. And this is the source of the, 2 meters, 6 feet away from other people, which actually is kind of historical. Some people think, including Lindsay Marr, it should be more like 10 feet. Yeah, if you really think about the physics of viruses and aerosols. But, it's an arbitrary thing, this 5 micron happening at close range only. It's an arbitrary cutoff. Okay, and anything less than 5 microns essentially is considered an aerosol. So it's hanging around for a long time. Okay, and that 5 micron cutoff is just historical. Okay, so what do we know? So we know a little bit about other viruses. I don't want to go into that literature. I just want to be as direct and basically use SARS-CoV-2 data if we have it. These are the different aerosol sizes in a Chinese hospital. And again, these are RNA numbers, so copies per cubic meter. And you can see that, between 0.25, 0.5 microns to 1 micron, that's kind of like the distribution. Okay, so it is, being aerosolized, and these are the numbers. This is the famous paper, and there's a lot of data here that you may have heard that basically aerosols and then how long viruses are stable in different surfaces, copper, cardboard, stainless steel, plastic. This came out also, and a lot of people and a lot of media started citing this, basically saying, 3 hours in cardboard, or maybe 24 hours on cardboard gives you the 3 or 4 log removal. On copper, it's quite fast, just a few hours. What about aerosols? So here, the aerosols, again, in the order of something like 3 hours, right? For about a 1 to 2 log removal. And that's where it's an issue now, right? Because if this is correct, then if if SARS-CoV-2 is in the air, it's in the air for about 3 hours before it's deposited. Um, now, uh, so the half-life, looking at this lower left hand here for aerosols, is about 1 hour or so for SARS-CoV-2. In comparison, SARS-CoV-1 is about the same, statistically the same. Okay, and the 3 hour cutoff is kind of like here. Um, uh, what we need to remember is these lab conditions. Okay, this was an experiment where they created the aerosols using a nebulizer in a chamber, and they measured it from that chamber. So this is not real life conditions. What we know in terms of real life conditions is from measurements from hospitals. Here's another experiment that basically is showing what happens when you flush your toilet. Okay, they looked at toilet flushing, and they looked at the aeration basin. This is an activated sludge wastewater treatment plant basin where you aerate the reactor, so you supply oxygen, and so you're actively aerating it. And the idea is that there may be aerosols produced. And these are converging pipes in sewer lines. So they designed an experiment where they were simulating how two pipes converge, and that turbulence might create aerosols. And so you do create aerosols, about 10 to the 6 in terms of the number, but in terms of total volume, it's very little. It's 10 to the minus 9 mils. That's a very small volume. If you multiply that by the number of viruses that you might have in a mil of water, let's say you're at 10 to the 7, 10 to the 8 gene copies per mil, then really there's less than one virus per mil. You multiply this very, very small volume by that concentration. So in fact, if you look at toilet flushing, these are the rates now, and this is for Ebola virus surrogates. You basically don't have any PFUs per flush, and aeration basins are much higher than converging pipes, but it's still not a lot. Okay. So toilet flushing has low risk of emitting aerosolized viruses, according to this one study. And this other graph here is just that same study showing that aeration basins. This is the mixed liquid, the liquid underneath, and this is the aerosolized number, the blue one. Aeration basin versus converging sewer lines. Another study by the same group was looking at how viruses partition in different materials. For example, between concrete and polypropylene and porcelain or PVC. The idea is that, do they stay in the liquid, or are they in the solids, or do they go into the air? And the idea, and the results are, most of them are actually still in the liquid. So 96% or higher is in the liquid. So they're saying there's really not a lot of chance of aerosolizing. Okay, so here are the major unknowns. The transmission routes, which ones are the most dominant, how much virus is released in different size aerosols and at different stages of infection, how are they inactivated in air and on surfaces, and how do they survive in real world conditions. So there's still a lot we don't know. Okay, so this is the overall summary. SARS-CoV-2 is easily inactivated, and that's why people say disinfect surfaces and wash hands. Wash hands well with soap. Your properly treated drinking water is very safe. No worries about that. But if it's untreated water, be careful. There's a lot that tells us that, there's obviously, it's in fecal material. But whether or not it's aerosolized, it's still not quite clear. But in raw sewage, assume that it's got SARS-CoV, and so stay away. Anyway, you have to stay away from raw sewage, right? Not just for SARS-CoV-2, but for all kinds of pathogens. Natural waters like lakes and rivers, if you suspect fecal contamination, I can tell you that the fecal load is very high in a lot of areas. Um, then just stay away, right? Don't get into your eyes, don't get it in your mouth, um, you know, and so on. Aerosolization is a low likelihood, but again, abundance of precaution. And so for wastewater personnel, proper personal protective equipment, PPE, is needed, but there's nothing special about it, right? So face mask, glasses, gloves, all of those things. And if you get a splash on you, just wash it. And the WHO has the same recommendations, as well as the Water Environment Federation in the US. We do need to do more research, as you saw. A big issue is the dose response, right? What dose re- uh, gives us the response in terms of the disease, and also understanding exposure pathways, and maybe environmental surveillance, including wastewater-based epidemiology. So our group is starting to do some sampling of wastewater treatment plants here, and we intend to add to the data that's being collected right now all over the world in terms of wastewater as a way of uh, surveilling or sampling a huge community, a pool of people, um, and maybe that can help with the public health data. Um, so right now, like most people, we should stay at home and our labs are closed, but we're collecting the samples, putting them in the freezer, um, so that we can do that study later on. And with that, I think that's the last of my slides. I'm going to stop sharing and see if we have any questions.
Thank you so much, Francis. So I think that was a very informative talk, and we really had a very good reception when we announced this particular talk. So we have a few questions from those joining us in Zoom, and also a few more on YouTube. So I'll begin with EB Agustin. So in a municipal water treatment plant with raw water source from a protected watershed, which disinfection treatment do you recommend more? Using the UVC or using chlorine? Some people are worried about the toxic effects of chlorine.
Yeah, so in general, both are very effective against SARS-CoV-2. If you kill E. coli, if you kill Cryptosporidium, you're killing SARS-CoV-2. Um, what you're talking about in terms of the health impacts of chlorine is when chlorine is put in water with lots of organic matter, then you have these
Mhm.
reactions that form, chlorinated
I think
compounds,
it's
chloroforms, and bromoforms, and so on, halogenated compounds, and these are carcinogenic. Um, by the time that the chlorine is added, this is towards the very end of the treatment process. There should not be a lot of organic matter in the water. So most of that organic matter would have been removed already, and therefore the risks of forming these halogenated compounds, trihalomethanes like chloroform, are quite low. Um, so chlorination is a standard practice. It's a practice that is one of the top 10 engineering achievements, saved a lot of lives over the course of human history. Um, there are some issues if you add it to water with lots of organic matter. But in drinking water treatment, I wouldn't be too concerned about it. There are measurements for trihalomethane formation potential that you can do. So make sure that you're below those numbers, so that you're not worried about chloroforms and bromoforms. UV is good, and again, it's very effective for SARS-CoV-2. But for drinking water, UV does not have a residual. In other words, you zap it and the water flows through. That's it. There's no staying power of the disinfectant. With chlorine, you have a residual because as it travels through the pipes, it still has a little bit of chlorine. So UV can be used, but typically the practice is to have a residual, and so that's why you need other chemical disinfectants. For wastewater, before you discharge into a receiving body of water like a river or a lake, UV is great because you don't need to have a residual. You don't need to add disinfection going into the lake, right? You don't really want to kill the fish in the lake, or so UV is perfect. With chlorine, when you chlorinate wastewater before you discharge, you actually have to dechlorinate, take out that chlorine.
I see. Okay, so we have another question from Angela. Is it typical for wastewater treatment of domestic or hospital wastewater enough to treat the virus, both biological and chemical treatment?
Sorry, can you say that again? Is
Is
the
the
first
typical wastewater treatment used perhaps in domestic and hospital wastewater enough to treat the virus, assuming that it
yeah,
uses both biological and chemical treatment?
yeah, and the answer is yes. And again, SARS-CoV-2 is less resistant than other organisms, than the non-enveloped viruses, than other pathogens in the water. So in fact, it's easily destroyed. So the problem with SARS-CoV-2 is not that it's hard to destroy. If you wash your hands, you actually are destroying the virus already.
Mm-hmm.
With soap. Um, the problem is you know, the infectivity, the transmission. That is the problem, and it's easily transmissible.
I see.
Yeah, but it's easily also disinfected. So that's the good part. So yeah, if your wastewater treatment plant is, even if it's hospital waste, if it's working great, working properly, then it should be fine.
Okay, we'll take a question from the YouTube comments. This one's from Al James. He wants to ask, what is the limit of detection for SARS-CoV-2 in fecal samples as well as in sewage?
For RT-PCR, that's a good question. A lot of the people who are reporting now, um, and publishing, they're not necessarily publishing their limits of detection. Um, but with RT-PCR, um, you can go down to maybe 50 copies per mil, with another technique called digital droplet PCR, or ddPCR. There's a paper that came out just the other day that showed they can actually go down much, much lower than that, down to less than 1 copy per mil. So that's more, that limit of detection and limit of quantitation is much, much lower. Um, so I think we can detect them to low numbers. There's the other issue of false positives and false negatives, and that's a matter of how do you control. And right now there are different primers available. You saw the N1, N2, N3. There are different primers that people use, um, and I believe some are better than others. But again, people are using right now. We're still sorting this out, and people are using what primers are available out there, and maybe some are better than others. I'm sure that in the next few months we will find out. Research is going to be done that shows, okay, here are better methods than others.
Okay, one from Samrin. He has a question not regarding transmission through drinking or wastewater treatment, but rather what would happen if people share swimming pools, which are with infected patients?
Yeah, so this was addressed by the CDC um, in the US, and essentially the chlorine in
Mm,
swimming pools would render the virus inactive. So it's safe to go swimming
okay, that's good
in,
to know.
in a properly treated swimming pool.
Okay, okay, one from Christina. Will a population get infected by the virus if your water source is from groundwater?
That's a good question. As far as I know, nobody has, blanket statement. Nobody has found even the RNA, and definitely not infectious virus, in drinking water. Okay. So, again, properly treated drinking water. Groundwater, um, again, in general, is cleaner than surface water, right? Because it's been filtered through all these layers of soil and gravel and so on. The problem is if groundwater is impacted by fecal matter. So sometimes groundwater can be impacted by septic tanks, right? We
Yeah.
saw in that one diagram, you might have percolation of fecal contacted water, and it might hit your groundwater source. But there's a lot that we don't know, absorption to the soil and so on. So in general, it should be clean. I would trust groundwater, and unless it's really contaminated. And sometimes it can be obvious if it smells bad or so on. That's for chemical contamination, but for fecal contamination, you might have to have it tested.
Okay, thanks.
It's also important. Sorry, one more thing that we don't do usually in the Philippines. It's important once in a while actually to clean our the pipes
Hmm.
in groundwater once a year. You should actually dose that with some bleach, and so you want to clean a little bit of that. That's not usually done. Yeah.
Okay, thank you. So another one from our YouTube viewers. This is from Francis. Is it safe to use water? Oh, okay, it's probably similar that comes from deep well, and how likely water that comes from deep well will carry SARS-CoV-2? So
Yeah. So again, it's unlikely. And again, you know, so the issue is, uh, the virus gets into the respiratory system, right? Now, obviously, when you eat or drink something, it goes into the same mouth and the same pharynx, right? But then there's a separation. Um, so they're connected at the front end, right? But there's a separation. So oral is different from respiratory. So the issue there is if you have it in your water, right? And let's say you have a lot of virus in water, and maybe you know, touch your eyes, and then that tear ducts are connected essentially to the nasal, or you get it into your nose, inhale it somehow, right? So that's the issue there. Uh, but in general, again, properly treated water, it should be safe.
okay, so one from Chris. Do you think there's capability in the Philippines to test the wastewater as a way to detect COVID-19 virus presence so that you can augment human testing?
There is. We have capabilities in the Philippines. Right now, I would say that we should prioritize human testing, right? Personally, I feel like we should not take valuable instrumentation, personnel, and equipment, um, and time and energy to do the wastewater stuff. If those same equipment and reagents are being used for human testing, we should not prioritize wastewater testing. That's my personal opinion, right? So, but we have equipment in the Philippines. In fact, PAASE has been instrumental in advising our national government, and I believe there's a bunch of Cepheid machines that are coming, being imported, and these are the RT-PCR machines, and we have all over the country. We have some capability. Obviously, the need is great. So the answer is yes, we can do it. I mean, we have the Philippine Genome Center in UP Diliman, we have UPLB, we have the microbiologists all over in the universities and even in the state labs that can do it. Um, I'm just saying that personally, I don't think that we should take away the resources to do wastewater sampling and detection. I maybe that's an opinion. We can argue that's not, um, but yes, the answer is yes, we can do that.
Okay, thank you. A question from June. Does SARS-CoV-2 survive in rainwater? Does rainwater clear the air from the SARS-CoV-2 aerosol?
Oh, that's a good question. Um, uh, the numbers are going to be low. I think that's a good question actually. So rain as a way of clearing aerosols. So the issue is aerosols are not, they're always, they're being produced whenever you have a little bit of turbulence. For example, even the tides and the waves in the ocean, right? I mean, if you're by the beach, you can actually sort of smell the salty air. That's actually aerosols. Um, uh, so anytime there's turbulence, you get the aerosols. So it's true that for most airborne pollutants, rain actually can clean the air, right? There's deposition happening in the rain, the droplets. Uh, that's a good question. I mean, that's something that we need to consider. But I would imagine the numbers are going to be very, very low. Um, in rainwater. Obviously, it's sterile water, and if it's just relying on aerosols for the viral numbers, it's going to be very low. So it may not be a big impact, or there may not be a lot in rainwater. I guess uh, that's a guess, but that's my educated guess.
Okay, thank you. Okay, another one from Al. As discussed, SARS-CoV-2 sometimes cannot be detected in oral swab samples, but in fecal samples. So can we use fecal samples to effectively monitor the patients who have recovered from SARS-CoV-2?
That's a good question, and the researchers who report that are actually saying that same exact point that you said because the standard is you have to test negative two tests, right, before you are discharged, and also obviously asymptomatic, right? So you don't have the symptoms, and then you test negative twice, not just once, because there's a possibility of a false negative. Now, what the research is saying, those few papers, is that even after you test negative twice, so you might be discharged already, you're still seeing it in the stool samples. So they're still shedding, and on the average, I believe it's 11. I think that's the average. Um, so uh, it it's possible that maybe on the back end, even though somebody is already recovered, um, they might still be shedding the virus. Um, I think we'd have to have that discussion with the medical community, right? Somebody who's technically recovered,
Mhm.
they may still be shedding the virus, but they don't have any more symptoms. How do we deal with that? What's the and I'm not a medical doctor, so I don't know. But I'm just telling you what's seen from the data.
We have a question from Phil. If wastewater with nCoV-19 is exposed to sunlight within 8 hours or more, will nCoV still survive?
Yeah, some of the studies that were done with the UV disinfection actually were aimed at solar disinfection. As you may know, SODIS or solar disinfection is a way of actually disinfecting drinking water. Um, uh, 8 hours is a long time, depending on where you are. There is obviously UV that will hit that. Uh, I can tell you that if you are killing bacteria, you are already killing SARS-CoV-2. So SARS-CoV-2 is probably the easiest to kill with UV also. The disinfection rate constant for UV is about 5 times higher, which means it's 5 times easier to kill than some other viruses.
Okay, one from Lance on YouTube. What is the mechanism of an enveloped against naked viruses when disinfected?
Oh, so SARS-CoV-2 has a lipid envelope, right? Essentially, this virus and most viruses is just RNA and it's packaged, right? And so the package, the coating here, has a lipid or fat-based envelope. And when you have a surfactant like soap, you basically are dissolving that lipids. It's like you're washing your dishes, right? You use dishwasher soap or to clean your dishes. It's the same kind of thing. You're dissolving the lipids, and therefore the virus now is structurally not sound anymore. It cannot. It doesn't have the outer coating, the receptors, and so on. It's just RNA. So that's what makes it easy to disinfect.
One from Rachel Diaz. Are sprinkling and misting using chlorine dioxide effective in removing the virus?
On surfaces, or just in the air. I think you
Split
know.
lang yata yung
Sorry.
Sorry, that's just
Okay.
okay. So yeah, on surfaces, it's a matter of concentration and contact time, right? So uh, which we call the CT, C times T. You can have a low concentration, let's say of bleach, but there's a long contact time. It can have the same effect as a high concentration but short contact time. So when you're wiping a surface, right, you actually want it to stay there for a little bit because that's the contact time. So spraying it on a surface, presumably, yeah, it's in contact with the disinfectant, with the chlorine for a while, right? But if you're talking about spraying the air, uh, that is something that uh, most people don't think about. I mean, it's a lot easier to UV the air
Mm-hmm.
to disinfect the virus. Yeah. Um, Another way that people are using it, like the recycling of the N95 mask and so on. There's a hospital here, Duke Hospital. What they're doing is they're actually exposing it to hydrogen peroxide, and so that they can reuse the N95. So it's been proven. Yeah. So if you mean surfaces, then yes, it's a matter of concentration and time. If you mean spraying the air, uh, there are easier ways to do that.
Mm-hmm. Okay. So, okay, one from Jennifer. Could SARS-CoV-2 infect also non-human hosts like bacteria and fecal samples and pests and other animals?
So, I'm not. This is not my area of expertise. Um, there was a news item. So obviously, this is a zoonotic disease, right? In other words, it evolved coming from bats, likely. There's still an issue whether pangolins were involved. But if you look at the genome, um, uh, there's a very clear bat portion of it. So it's a virus that evolved from bats into humans. Now, whether or not this particular strain that we have right now can actually infect other animals, I don't know the answer. Although I did see a news item that a tiger had.
Yeah.
Was it a tiger?
Yes, yes, in the zoo.
In the zoo. So maybe. So again, it's not my area of expertise. I'm sorry. Yeah.
Okay. We have a question from Angela, but I think we discussed that already about testing, shifting testing from nasal to stool. And then one from Vic Ilag. How much is known about the formation of defective interfering particles with COVID-19? Is it possible that DIPs are the ones being detected in feces, especially if the assay is RT-PCR? A DI particle would look like a live virus under electron microscopy.
Oh, that second part. I didn't know that it might look like a live particle under electron microscopy. So false positives is an issue. Um, and again, it's an issue because if you use two or three primers, sometimes only one's positive and the others are not. So for example, if you use the N1, N2, N3 primers, most of the researchers say, okay, if we get two out of the three, we'll call it a positive. If we get only one, then we're not going to call that a positive. So yes, controls are an issue. I think that's really a big issue. I'm hoping that some of a lot of these papers also are very they did it very fast. If you read the paper, you know, there's not a lot of details on how they did things. Um, including how do you for water samples, how do you concentrate the samples? How do you make sure that you're not losing the virus as you're processing it? And then, you know, targeting, interfering particles. So that that's an issue, and I do think that a lot more careful studies are going to be done, and we have to take some of these earlier studies again with all the caveats, including the big caveat in that even if you detect the RNA, um, does that mean it doesn't mean you have infectious virus. Although, obviously RNA doesn't have a very long lifespan in an environmental system. So, it means the virus was once there, whether or not it's still infectious. Now, the part about electron microscopy, I did not know that. So that's an interesting thing. Yeah, there are a lot of questions right now with a lot of these studies. And I'm hoping that in the next months and next year, um, we can revisit some of these questions. Right now, people are scrambling and doing really fast science.
Yeah. Okay. One from June. So we discussed about the swimming pools. Will it be safe to go to rivers and the beach for swimming?
Okay. So my advice, if you were asking me, is a lot of our rivers are um, are polluted, and
Yeah.
and there's a lot of fecal load in a lot of our rivers in the Philippines, right? Uh, I would I would just avoid swimming in rivers right now because things are sort of we're approaching the peak. It may be safe once we're past the peak. That's just from an abundance of caution. What's my data? I know it survives in natural water, maybe for a few days. Um, what's the likely scenario, right? Well, you're swimming, you're inhaling things, you're swallowing things, and things get into your eyes, things get into your nose. Um, but there's a lot we don't know. We don't know the so-called infectious dose, right? How many virus particles will make you sick? We don't know that. Um, I mean, because the environment has a lot of pathogens, and it's okay. It's not clean. It's not 100% clean. It's okay. But if there's enough particles, virus particles, you might get sick. And the thing is, we don't know that number. We don't know the dose response, right? I shouldn't say infectious dose. It's more like a probabilistic mathematical relationship between dose and response. Um, I would just stay away if I think that river is impacted by fecal material. I guess that's what I would say. Um, Beaches are a little
Yeah.
bit different just because it's a huge body of water. I can tell you though that a lot of waste goes to the ocean and the seas. We don't have a lot of proper wastewater treatment in the Philippines. So yeah, uh, you know, uh, I would just be careful.
Okay.
And yeah, but chlorinated swimming pools are better.
I think there's a follow-up from Giselle. Yeah, very similar. What about COVID-19 in seawater or salt water, hypersaline, sodium chloride, nasooral drops, or sodium ascorbate drops? Um, can you comment on the likelihood of the virus in such an environment?
Yeah, again, we don't know a lot about the environmental fate of SARS-CoV-2. In terms of salinity, most people look at temperature, relative humidity. This is for surfaces. Salinity, I have not seen data on salinity. Um, if you know if it kills the virus or not. I guess if I may extrapolate the question, people are asking about mouthwashes, and in the Philippines, and we still do this. Um, when you have a sore throat, you
Mm-hmm.
drink, you gargle
Yeah,
with
yeah.
salt water, right? Uh, I don't know. I mean, I gargle with salt water when I have a sore throat. I don't know the impact on SARS-CoV-2. There's not a lot of data out there. I don't think it will hurt, but I'm not a medical doctor, so I'm not going to say that that's a valid um, preventive measure. Yeah,
Okay.
I think that, yeah, I'll leave it at that.
All right, so I'll take two questions from our YouTube viewers. So they are quite very similar relating to treatment. So the first one is from Huang. Would UV treatment be sufficient as a precaution for drinking water? While the second one is from Jennifer. What disinfectant would you recommend to clean toilets and eventually treat the septic tanks before the wastewater goes to the soil and the water system?
Yeah, okay. So let's see. The second one was toilets. Let me start with the toilets. I
Mm-hmm.
forgot what was the first one? Oh, UV. Let's do
UV, yeah.
that first. Uh, yeah, if you have a UV lamp, and particularly UVC is what you want, right? 254 nanometers in that range. Um, if you have that and you expose, your bottled water, let's say, or drinking water for, maybe 20 to 30 minutes, and I'm just making a guess in terms of just intensity and time, but I'm going to say if expose that for, 20 minutes at least, um, you should get, uh, um, you know, several logs or several orders of magnitude inactivation of SARS-CoV-2, um, and really most anything else, but definitely SARS-CoV-2. In terms of cleaning your toilet, any approved disinfectant, and the CDC has a list, and the EPA has a list of approved disinfectants. I gave a list there in one of the slides where we talked about a chlorine bleach solution, um, you know, quaternary ammonium compounds. And so if you look at the cleaners that you have, you're going to see exactly what they have, right? And that's a very common cleaning agent, quaternary ammonium compounds, uh, peracetic acid, peroxyacetic acid, but mostly, bleach, chlorine based. And so you can wipe down surfaces. And again, this is just, precautionary. Obviously, if you have somebody who has it and is sick and they're using that toilet, it would be nice if they had their own toilet. But if they're using the toilet, then you want to clean it maybe twice a day with the proper PPE, right? And so, because there's a possibility of splashes and aerosols on surfaces. But some of the data is saying that, it's not a big risk. In terms of putting things into your septic tank, I wouldn't necessarily do that. I guess, uh, because the septic tank is, whatever you do, it's not going to be enough for the billions and billions and billions of organisms that are in your septic tank. Um, unless you really, you know, pump it with bleach, there's going to be all kinds of organic matter and bacteria and microorganisms in that septic tank. So it's not. It's like, yeah, it's not going to be enough. Um, and also, in reality, the septic tank is a biological treatment system. The idea is that you have these microbes in your septic tank that eat the organic matter in your wastewater. That's the idea. Um, uh, on the other hand, if you think about treating the effluent, um, in a decentralized treatment system, I think that's possible. But I would not, you know, do that on a household system with dumping chemicals down your toilet.
Okay, so again, I'll lump some questions together. They are very similar in nature. So this is about the virus in the feces. So Jonalyn said there is an effect of time with regards to the determination of the presence of the virus. Would that imply that people affected by this virus have discharged their feces wastes in wastewater into the sewer line, does not have any disinfection, could impact the remainder of the sewage system as it passes through with a given time? What do you think is the duration that the virus will still live in human feces? Well, somebody from the YouTube commented about epidemiological studies and wastewater surveillance. If it's possible for a patient to shed more than another, and if so, how is the accuracy assured when you test the actual number of infected patients? I suppose this is with regards to the pooled sampling.
Right, right. That's a good. That's These are good questions, and some some of the answers we still don't know. It is true. There is a variability in terms of how much is being shed by individuals, right? So there's going to be a distribution. Um, as far as we know, it's about anywhere from, again, there's a whole range in terms of 10 to the 7, 10 to the 9 gene copies, right, per gram. Um, and that's just the more we sample, the more we'll understand this distribution. Um, so when we're modeling this and figuring out or back calculating how many people had that infection, we are actually assuming that you know on the average we can
Yeah.
make this calculation, right? But really, there's a distribution associated with that, and we don't know enough. We have not sampled enough. Fecal samples from different people at different stages of infection, right? And different kinds of people, from children all the way to older people. So we don't know enough about that shedding. We have some idea from other viruses, but not a lot. Like from the original SARS and MERS. Um, uh, we know it's being shed in huge numbers, but we will assume an average when we're modeling these things. So a lot of these models, you have to be looking at confidence interval, the variability of the results, and it's still going to be huge until we get the data to actually know the numbers. So that's one. Once it's shed, it goes to the sewer line, let's say, right? It takes a
Mhm.
while from your house, from your toilet to get to the treatment plant. And we don't know enough about this. We just know we can detect it at the treatment plant. But we don't know so presumably in the 3, 4, 5, 6 hours it takes to get to the treatment plant from your house, or maybe even up to a day, right? That we can still detect the RNA. But again, there's a lot of unknowns, right? We need to understand what's happening there. And again, modeling these things is the way to do it. But models are only good if you have enough data. And so far, we don't have that data. What we're doing in Raleigh uh, is we're sampling the wastewater treatment plant influent. So that's the whole or big portion of the city. And then we're also sampling some neighborhoods, so smaller areas. And we're hoping that with this data and knowing the sewer lines and the network, that we could um, eventually come up with a model that will help us understand some of these things that you're asking.
Okay. All right. Yeah, we have a few more questions. Now, this all relate towards disinfection. So, I'll lump everything together. So, Jennifer is asking if 70% alcohol is being used as a disinfectant in most laboratories. So, is this still effective against the SARS-CoV-2? Other questions would be, does sunlight disinfect the aerosols? And there have been some suggestions that people should go out to be exposed to the sun. Do you think this will develop their immunity of the virus? Or is this a good
Oh,
suggestion? Yeah.
okay. I don't know about immunity. That's a big question, right?
Mm-hmm.
Okay. So let's start with the 70% alcohol. Okay, so that works on surfaces, right? And that's fine. I think that's okay for sterilizing surfaces. Uh, in water, alcohol is not used as a disinfectant because it's diluted, right? Once you
Yeah,
put it in
eventually.
water, yeah, so there's no effect. But on surfaces, uh, that's used, and also hand sanitizers, right? Alcohol is the base for some of these hand sanitizers. Um, Sunlight going out, uh, definitely not to get immunity. Immunity is a big loaded word here, but uh, we talked about sunlight exposure and the UV in the sun is possibly disinfecting, water. If you put it out there for hours and hours, right, there's going to be some log decrease in the infectivity of the virus. For you, if you, let's say, have a virus on your, I don't know, on your skin, uh, it might be hours and hours before, and there's so many different factors. I guess that's the thing. It's very hard to have a general statement. uh, I almost imagine that you might get sunburned first before you actually get an appreciable decrease in the virus. You just better just wash your hands, then you're done, right?
Yeah.
Um, so I think that's the answer. You won't get immunity by being out in the sun. Obviously, we're all inside our houses. You want to go out just for your sanity and just to get vitamin D and just to breathe some fresh air. But in terms of disinfecting yourself by staying under the sun, I think you have to stay out for a long, long time. And it's just better to take a shower or just wash your hands. Yeah.
Okay, thank you. I think we're done with all the questions. One more thing, Francis. Can you share with us the slides so that at least I can email the PDF version to those who of our registered participants?
Yeah, I will take a look. I think, yeah, I'll take a look at the slides. There may be some pictures that I, have to get approval for, but otherwise I can send you the PDF.
Okay, thank you. But before we end this particular session, so I'll just share my screen to plug the
Sure.
next webinar for next week. Okay, hold on. Okay, so for everyone who's watching, so next week we're having the fourth PAASE webinar. So we've talked a lot about the COVID virus. So we did the modelings initially, and then we had somebody from NIH last week. It was Dr. Anna, and then today we were talking about the fate of COVID-19 in water and wastewater. So next week we'll talk about the economic impacts of COVID-19. So we'll have Dr. Krista Daniel Yu from De La Salle University to talk about post-pandemic recovery modeling. So again, this will be on Friday, 8 a.m. for those in the Philippines, and Thursday, 8 p.m. for those of you in the US. So if you're interested, please register and go to bit.ly/KDYU. Okay, so I guess that's it for me. So thank you so much, Francis. Do you have any parting words before we close this forum?
Uh, uh, no, I think everybody, just practice again, safe, physical distancing, proper hygiene, and we'll get through this, obviously.
Okay, thank you. Thank you so much, everyone. Thank you, Francis. And hope to
Thanks.
see you guys next week.